Hello, my name is Kellyn. I'm a Senior Technical Consultant for Encatech, and this is Database as a Service in a DBA world. Before we begin, let me tell you a little bit about myself. I'm from Westminster, Colorado, which is a suburb outside of Denver, Colorado, between Denver and Boulder. I'm an Oracle ACE Director, I'm an Oak Table member, and I'm an evangelist for women in technology. I specialize in performance tuning and management of large enterprise environments, and I enjoy performance tuning on Exadata, very large databases, and I'm known for my expertise in Enterprise Manager 12c. I'm on the board of directors for Rocky Mountain Oracle User Group. I am the director of Training Days, which is a conference that will begin tomorrow on February 5th. I'm also the database track lead for Kscope, which is ODTUG's conference that will be happening in June in Seattle, Washington. I blog at dbakevlar.com, and I tweet a lot at the handle dbakevlar. Down in the right-hand corner are images from two of my books. One is a little bit better known, from the Oracle people, of course, which is the Expert Oracle Enterprise Manager 12c that I'm the lead author on. I've also co-authored the ProSQL Server 2012 Practices. Both of these books can be found from Apress. This is the disclaimer that you're all familiar with at this point in the series. I'm going to leave it up on the screen for a couple seconds. With that, we'll jump into this introduction to Database as a Service. Database as a Service is an architectural and operational approach enabling DBAs to deliver database functionality as a service to internal or external customers. There are many companies that are providing database as a service. You'll see them in Amazon EC2, GoGrid, Salesforce, Rackspace, but with Oracle, we're now providing it with Oracle products as well. Database as a Service architectures support the following required capabilities: customer-side provisioning and management of database instances using on-demand self-service mechanisms. This means that there is a self-service portal that is available to the users to request anything that they might need. Automation of monitoring and provider-defined service definitions, attributes, and quality SLAs. This also means that the DBA can provide these services without putting pressure on them in their day-to-day demands that are on them already. If you have users that are used to coming to you and demanding things right now, this day, this is something that you can put out there, and customers can put in requests, and they're provided for after you've set up the Database as a Service environment. It also allows fine-grained metering of database usage, enabling showback reporting or chargeback for both internal and external functionality for each individual consumer. Chargeback is becoming very, very important to cloud control. As we go into the cloud, being able to keep people accountable for the usage of IT operations and resources is extremely important. Many people have told me that they don't understand exactly why Database as a Service will ever be an option for them or something that they will require. This is an image from Pete Sharman, who works for Oracle. As you notice, there are 1 million targets here. That means that there's probably about 400,000 databases. Half of those, a fourth of those, even an eighth of those. None of us want to have to create that. The ability that you could have a self-service portal that people would request it and it would provide those databases is really a positive option. So why Database as a Service? DBaaS standardizes and optimizes the platform requirements, which eliminates the need to deploy, manage, and support dedicated database hardware and software for each project's multiple development, testing, production, and failover environments. We often, as administrators, are servicing so many customers, and everybody is expected to do more with less. The Database as a Service architecture is inherently designed for elasticity and resource pooling. They deliver production and non-production database services that support average daily workload requirements and are not impacted by resource limitations, time-sensitive projects, hardware, and limitations on budgets. If you can see the actual image on the right there, We have pluggable databases, clones, schemas, and dedicated databases that all can be provided through this service. Again, we're trying to come up with the idea of is the time now, and the time is. 451research.com stated that database as a service is arguably the next big thing in IT. Indeed, we projected an astounding 86% cumulative annual growth rate with annual revenues from database as a service providers rising from $150 million in 2012 to $1.8 million in 2016. That's a lot of revenue dollars. If you look at the graphic below, you can see that out of the 32% that was planned to be adopted in 2013, almost 20% of that was dev and test. Dev and test really do see a great opportunity in database as a service. So how as DBAs can we embrace DBaaS? We all know that the great DBA automates everything, desires new learning opportunities, desires a secure, controlled setup for a self-service portal, and approaches challenges and answers with simple, robust options. Database as a service offers this. It allows us to automate everything. It gives us the opportunity to free up those resources so that we can take on new opportunities. And it is a secure environment that we know with the framework from EM12C, we don't have to worry about a lot of the challenges that we would have to do if we were using manual scripting options or something that was built outside of the Enterprise Manager interface. There are many options with the database as a service. This option that you're seeing here in the graphic, the EM12C database as a service, you can see often that we're using the DBCA template. So that's Database Configuration Assistant. It then builds into PaaS, Platform as a Service storage. It creates database pools, defines quotas, and then creates finally a service template that can be utilized with DBaaS. Next option you see here is a snap clone. It uses an RMAN backup, Database Configuration Assistant template, and you can even export a schema. Then you have another option with an RMAN backup to deploy a database. And then you have Schema as a Service. This acronym SaaS is also used for Software as a Service, so ensure that you're utilizing the right acronym for the right product. You can import objects in with Schema as a Service and choose to either import the data in or no data. The summary of the moving parts is, again, we're doing a lot more with less. We have less resources to allocate towards tasks. And the question is how much of this are you already doing in your day-to-day life, but you're doing it in a very manual way. Part 1, we're going to go through the different DBaaS scenarios and options, and 2, understanding database as a service security and roles. Looking at a DBCA fit in the equation, you can see that here that we have a DBCA template, platform storage, and a database pool that creates a service template, which is one way of creating a DBaaS option. All of us most of us at least, have used a DBCA template in other ways. We've either used it through the GUI or we've used it with the silent install option. This is the same thing that you're utilizing when you actually use the DBCA, the Database Configuration Assistant, with the actual Oracle environment now to create a database. It's used now as part of DBaaS. You can also create a DBaaS clone. This is done by creating one from the production database. They create a copy. There's any masking or subset of data that needs to be changed, you can do that. Then you have a test master database, which is then utilized to create functional database copies. Next option is Schema as a Service. Now this is a data pump option. Data pump of the schema is created. It's then utilized by a service template, and then it can be imported into a target database with or without objects, or without data. Setting up database as a service, there's a lot of different roles that are involved. We're going to hear a lot about the cloud administrator. The cloud administrator will define the roles and users in the self-service portal. They'll be installing the agent to manage all unmanaged hosts, so self-discovery of DBaaS environments that are created. What that means is any databases that are created through DBaaS are automatically discovered and managed using monitoring templates so that the DBA doesn't have any mystery databases sitting out there. That can be very frustrating as a DBA. You set quotas and privileges to ensure that no resource is overallocated, and software libraries will allow automation of the creation of Oracle homes. Provisioning will set to be granted and how much allocated to each customer, administrator, and/or user. The self-service portal design is very simple. It's often performed by a self-service administrator, but again, this usually falls within the DBA realm. Oracle homes are utilized by one or more multiple service templates. Templates serve as the DBaaS options to the self-service portal for customers, and roles are designated to the self-service administrator, but again, this is often the DBA. You can see on the left-hand side in the graphic, the provision Oracle database software is then set with a configuration to the listener, and then the different choices from the template are built out from there. So you have snap clones, RMAN backups, DBCA templates, schema as a service, and you can even create a database off of that one. And then of course 12C options, PDB as a service, and create container database. Part 2, we're going to go through the next steps, which are registering storage, creating the platform as a service, also known as PaaS, and utilizing PaaS to create the PaaS infrastructure zone, also known as the iZone. To access database as a service, we'll go in through the EM12C console, from Enterprise, go down to Cloud. The second options are going to be in the right-hand side menu in Setup. We're going to utilize those from Cloud, Provisioning and Patching, and Manage Cloud Control. The first step is to register the storage. This again is accessed through the Setup on the right-hand side. You'll go into Provisioning and Patching, and then go into Storage Registration. There are two options available currently. You'll see NetApp as well as ZFS storage, but soon you will see Exadata, VMs, and they're saying OVM, but it'll probably be Nimbula. The settings for the storage, this one here that you're seeing in the image is for NetApp. You'll actually look at the name, the NetApp there is the choice on the vendor. We decide if it's HTTP or HTTPS. We're going to choose the storage credentials. These are the named or preferred credentials for that item that target to log in. You can set up any aliases, and then you can go into the agent to manage the storage. Of course, this is what's going to do the auto discovery as people add more databases to it in the requests with the database as a service. Once you set up everything, you're going to actually see these in the list of storage registrations. And you can go through and you'll see the name of the registered storage, the type, the size, the storage ceiling, how much space is being allocated to the Enterprise Manager agent, total, status, and when it was last synchronized. Sometimes this is good to look at. If the information doesn't look right, it may be time to synchronize again. The next step is to create the Platform as a Service Infrastructure Cloud now that we have our storage all registered. You can get to this through the Middleware and Database Cloud menu to create PaaS Infrastructure Zone. We already have one that's set up in our actual database cloud, so we're going to look at that. It's called the Development PaaS Zone. You're going to want to set up a PaaS zone for every one of your environments. That means development, test, QA, production. You want to keep them simple. Simplest designs are the easiest to manage, and it also makes it easier for sellers' chargeback designs that'll ensure simplicity and PaaS, effective for the business. You don't want it too complicated, otherwise your users won't know what they're being charged for and a lot of questions will come up. The steps to setting up a PaaS iZone, as we see here in our existing one that we're editing. The developer's PaaS zone. Notice the placement policy constraints per host. Placement policy constraints allow the self-service administrator to set maximum ceilings on any host in the PaaS infrastructure zone. For a production system, you're probably going to want to keep these ceilings at about 80%, but with a test or dev QA environment, you may be able to throw them up to as high as 95. For this development scenario, we're going to do 90% on CPU utilization and memory allocation. Next is to choose a role. This is a development environment, and we've created a role called Developer. This is an SSA, the Self-Service Administrator user role for all developers. The last step is the review of the pass setup. Note that we have our developer pass zone, along with the description. It's pretty much the same thing, developer's pass zone. Our utilization and our allocation for memory are both at 90%. We have our named credentials, which are the credentials for this actual storage area, our targets, and then we're using the developer role. Clicking submit will end up creating this, and it'll be ready to go. Part 3, setting up the database pools and profiles, setting up request settings, self-service portal settings, and the DBA quota control, which is important to everyone. Setting up pools and profiles. In the setup menu, which of course is to the right top of the screen, the database pools contain a set of resources that can be used to provision a database instance within PASS. Profiles are information collected from a database to set up a database part of a service template. Service template is one of the final steps in creating your database as a service environment. You can click on Setup, Cloud, and then Database to enter this area, but do note you can create your infrastructure from here, middleware, and testing cloud sections as well. The interface is very easy to use. You'll notice that on the left-hand top side, the wizard will take you through each of these steps: the database pools, request settings, quotas, and then the final step of profiles and service templates. If you need to go into Chargeback, that is a separate section for this. The database pools that we have available now is 11202 SID-B. We're going to utilize this. This is a separate pool for single instance 11R2 databases. The database profile that you notice here when we edit it, it says 11202 SID-B pool. We've made a very clear description of this pool for single instance 11R2 database. There's no question what it's for. We have the host and the root credentials. Keep this in mind. A lot of administrators are having a hard time getting to understand the requirements of being a cloud administrator. Those roles were defined very clearly before, where you had a system administrator or a server admin that had root privileges, and the DBA may not have had any. That is changed with the cloud administrator role. You will have root access to this to actually enable the database as a service environment. So you will have host and root credentials set up in this environment, and no, there aren't any concerns about being hacked because this is in the EM12C security framework. You're going to have the Oracle Home set up. Notice that it's using the developer pass zone that we created earlier. It's a Linux x86 64, version 11202, and it's a single database instance. Down at the very bottom is an interesting piece of the setup, the placement constraints. Placement constraints allow the service administrators to set up a maximum ceiling for resource utilization. Often we know when we set up an environment how many databases max can be supported by that resource. This is where you would set that up. For this one, we've decided 10 is the max. We now enter the request settings. If you notice, the first one is future reservations. This gives the user the ability to put in a request, days, weeks, whatever we set up in here. For no restriction, they can set up as far in advance as they want. Restricted reservation means that they can say 1 week in advance, whatever we set here. Request archive retention has to do with the maximum duration, which archive requests will be automatically deleted from the system. This also assists in the actual dashboard view for the customer. Request duration is the maximum duration for which requests can be made. You have the ability to set this up for anything that you actually decide. 1, 10, 20 days, a month. The quotas for the requester are extremely important. Now keep this in mind. This is set for the amount of resources that the requester can use in the database as a service environment. This is not at the database level. So the developer here, the developer role quota is set at 100 gigs of memory, 1 terabyte of storage. They're allowed to request 20 databases, and the schema service requests are 10. This is at any given time. So as they drop databases, remove databases and schemas, that of course allocation will be returned to the developer. You can edit these within the system at any time. So if you have a developer that maybe they need less storage or maybe they need more, you can edit this within this interface and make changes. Number of databases can be upped. Number of schema requests can be changed as well. Database as a service has a number of different layers of roles. You have storage administrator roles that you see here at the bottom for the Enterprise Manager Storage Administrator and Enterprise Manager Storage Operator. These contain the storage roles that you see at the top: View Any, Register, View, Manage Any, and Full, as well as other options. You then have the target privileges to Snap Clone and Full. We've built our foundation, now it's time to glue it all together. Your framework will create your database as a service environment. It's finally time to build those profiles and the service templates that will be used as part of the self-service profile or portal. With the profiles in place, we're going to take a look at these ones to give you an idea of what you can create. The ones that you see here, you have an RMAN online backup provisioning profile for a reference database, then provisioning profile for a reference database, and a DBCA provisioning profile for a reference database. Each of these are database requests, and they're also very self-explanatory. One is using an RMAN backup, other is a thin clone, and the last is a database configuration assistant template. Each of these are used as the source. The next is the final piece, the service template. As we saw in the actual designs earlier, you can take each one of these and they piece together into the service template. You have these service templates at the bottom here that are the Create Reference DB using NetApp snapshots, the DBCA structure template for Reference DB, the full clone of Reference DB using RMAN backups, and a template for an empty schema provisioning, which of course is a schema as a service. Note that each one of the profiles correlate to a service template below. To create a template from an existing database is quite simple. Going into the wizard, you can choose a database. In this instance, we create one from a database named Reference. We decide that we want to clone the database home along with the database. We want the data content, the structure, the data. We want to create it from an RMAN backup. We have the choice to create it from a database configuration assistant template, which is the database template, a storage snapshot, which of course would be from a ZFS or a NetApp, and we can also use previous RMAN backups that are still existing within our catalog or control file, or we can do a schema as a service, which is an export schema objects. You can see below our credentials that are utilized for the database home and the database. The database home, of course, is a host credential, and then you have your database credentials that are sysdba. To create a template from a DBCA template or snapshot, you're going to see one that we're going to name very clearly, Create Reference DB using NetApp Snapshot. It's a single instance, but if we wanted to create a rack database, we could do that easily and decide how many nodes we want to utilize. This can be created from a single database. So think about this as you're having to go to like a rack environment from a single instance. This would be a really nice way to create that environment. You can also decide how many nodes that you want. If you're going from a rack and you want to create a new one and only you have 2 nodes, you could do that, or a single node rack environment. The identification, this is kind of interesting. You can choose what your SID prefix is. The one that you see here is SSA. So if I was creating a test1 TST1 database, it would actually be named SSA TST1. The domain name is there along with the port. This port will be utilized for all templates utilizing or all databases created utilizing this template. The next step is to actually set the parameters, decide if you want to turn on auditing, configure values for memory, recovery, and undo, and decide if the actual SSA admin has the ability to edit these values. Remember, this is at this template level. This is not for the Database as a Service portal. So this is for the database that utilizes this template. Then you also have the ability to use custom script options. You can create scripts that will save you time that you may have done previously through manual intervention, such as resetting sequences, resetting DB links, anything that you need to do to create that database to look like it needs to once the cloning process is finished or the creation of the database is finished, you can put here as a manual script. So what platform as a service will your template use? For this one, we're going to use our developers pass zone. I think you'll remember that we created this. This is our infrastructure zone, and it's our 11202 SID-B pool. This is our database pool that we're pulling from. What roles will we use? We're going to use our developer role that we created before. You can see how this is starting to come all together. Last piece is to review our new template. This is using all the pieces, the infrastructure and foundation that we created earlier to create a reference DB using a NetApp snapshot. And remember, we can reuse a lot of these pieces as we create other templates, such as ones using RMAN backups, ones that are schema as a service. We can reuse those pieces and then create templates based off of those with different combinations. For the storage on this one, you're seeing the reference mount point, all the naming, additional space needs, if there's any scripts that need to be executed as part of the creation at the end, initialization parameters. We've decided we're going to turn on auditing at the DB level, the zone we're going to use, along with the roles, and the role, of course, is developer. When we're finished, we'll click on Submit. We've now finished setting up our Database as a Service environment, and it's ready to use. As the DBA, you might be curious how we're going to manage this. The Cloud Administrator's interface is very user-friendly. Resource usage, consumption, all of that is available through the interface. You're going to see your databases, requests, usage for CPU, processing time, along with what's open and what's closed for requests. The self-service portal for the user is just as user-friendly. It allows a requester to view all information from just a few simple tabs in the M12C Cloud Console. You'll notice on the left-hand side, the usage is shown with graphs displaying the amount of databases that are used versus available, schemas used, available, memory used versus available, and then storage. You can view databases that are up, including down, which ones that are available, when they were started, and if there's any request to actually delete the database. Chargeback information is available from here as well. To submit a request from that pane, you're going to click on Request and then choose Database. You can also choose Schema as a resource from this tab too. You select a service template. For this one, we will select Database as a Service RMAN SID-B. This is a single instance database. We will then click on Select, and it'll then submit the request within the portal. The user can easily manage the information as the SA admin. You can see on the left-hand side here, they can see what is being restored and what snapshots are available. They can decide to actually restore or delete these. This comes in handy if somebody is doing a series of releases and they're not successful. They can restore, go back to a previous snapshot, and then decide to delete a snapshot if they're satisfied with their outcome from an earlier one. This is all available within this left-hand side. They have the choice to start up or shut down the database. They can see high-level information about that database, the space usage, and resource consumption. Schema as a service is very, very similar. But if they need an actual schema refresh, it's not about requesting a database to be cloned. It's just asking for that schema. They have a choice of deciding, do I want data? Do I not want data? I just want the objects. All of that is within the self-service portal. The database is a copy request. is a simple request via the Database as a Service profile and template with the EM12C Database as a Service. You can see the actual information. It's all requested with the user ID, their password, and if they want it immediately or if they'd like a delay in the request. They click on Submit, and the request is made. Next thing I want to talk about a little bit is chargebacks. Chargebacks are a huge topic, and to understand the components and cost to IT, how to fund the IT organization for the unexpected demands from lines of business have led to Oracle developing its own chargeback mechanisms. These mechanisms allow the requesters that are part of any line of business, upon requesting services, to receive an internal bill or cross-charge for the costs that they have incurred, which are associated to the infrastructure, data, licensing, and other resource usage. The benefits of this are making departments responsible for their usage, as well as refrain from asking for resources that upon further reflection or insight may not have actually been required. Providing visibility to the heads of IT and senior management on the benefit and cost of database environments and its infrastructure. And it also allows DBAs to respond to immediate requests with a positive response when resources are limited. The concept of chargebacks is a new one. How many lines of business pay for their own electrical usage as part of an organization? Having the ability to hold departments accountable for the demands they put on an IT organization is crucial to company success. Flexible chargeback plans allow lines of business to expect expenditures of a fixed allocation of IT services and gets the scalability they desire due to automation of DBaaS features. These demands by different lines of business on companies is quickly making DBaaS and cloud computing attractive option for many. The next option is kind of showback. Showback is a separate component of chargeback. This is the analysis of the IT costs due to each line of business to provide it to IT management and corporate without actually cross-charging these costs. The pressure on any line of business to limit their usage is less direct, but awareness of these costs usually causes senior management to question why one line of business is spending more than the other in IT. It results in them being a little more accountable. Now, as you're planning for chargebacks in the cloud, the M12C provides a great interface for cloud administrators to set up and build extended and universal plans to use with chargebacks. A universal charge plan is the simplest way to enable chargebacks and can be used for chargeback across a wide range of chargeback targets. The universal plan contains 3 metrics and no further metrics can be added. The 3 metrics that comprise the universal plan are CPU usage, memory allocation, and storage allocation through the Enterprise Manager 12c Cloud Control. This simple plan offers a one-stop shop for most DBaaS environments. If you notice the top left, you can see that we have 4 different metrics on this one. So I'm not real sure why it always says that there's 3 available. There's CPU usage for Spark, there's CPU usage for a default CPU architecture, a memory allocation for generic, and then storage allocation for generic. The next is the extended plans. The extended plans are for more advanced DBaaS environments. You set them up often by size, either small, medium, large, and also development, test, production, QA. The way that these are set up, you can see here in the images we have on the screen. Default, set up as large, medium, small for the VM guests, and then we can go into each one of those and see detailed information about them and see that they're usually a flat charge. They're a rate that's allocated towards this by month. Looking at the monitoring chargeback as a user is very effective through the M12C. We can see the charge plan set up from the chargeback interface, and you can see that there's a number of charges or a number of tabs. We have home, charge plans, cost centers, targets, and then the reports. We're looking at the report tab right now. These graphs within this dashboard show by cost center, by target type, and by resource. Know that you can actually click on the right side where the legend is and go in to get more information about those charges. The user-friendly interface offers detailed reporting, budget info for the consumer's fingertips. Notice that the chargeback information will show trending. It shows the base charges, the versioning, and universal rate adjustments, which are important to the business. Utilizing the self-service portal for a request is very simple. Notice here that we have a service template that we're utilizing, SOE DB service template. It is a 250 gig database request. The requester's name is utilized for the request name. It's the username along with a timestamp. The schedule request has been set to start immediately. The duration is indefinite. And then the actual user has to put in their username and password for the self-service portal to submit the request. Post submitting the request, the user can then go in and look at the database and see if the request has been fulfilled. Of course, 250 gigs is going to take time, so we're looking at one that is only 4.83 gigs. You can see that you have the capabilities of shutting down the database or starting it up. Look at the storage use, memory, the actual location of the storage utilization, along with different snapshots that you can snap back to if you have issues with something that you've released or a change that you've made. Customer service the database as a service way. The goal in database as a service is to have a self-service portal accessible to request and fulfill the IT needs of the business. Just as we see with any business, that means it must be carefully planned and mature to be successful. A mature database as a service catalog will offer the external and internal customers many options to choose from. Services are really just service templates. Note that these are most likely shared resources, so the user needs to be aware of that when they're requesting a product. In the catalog below, you can see that there's a small, medium, and large OLTP, along with a small, medium, and large OLAP environment. The CPU use is set there, server memory, storage redundancy, service availability, security options, which is extremely important to many people in a private or a public cloud environment, backup and archival, and if there's DR. As we see in this image, what does it mean for a database as a service in a standard environment? We can see on the left-hand side a standard infrastructure as a service with an OVM zone versus what we've discussed today in this presentation, which is a database as a service environment. The database as a service environment has requesters in the form of users that put in a request to the platform as a service, a deployment in the platform as a service zone, which then creates database homes, databases, and the middleware homes. So what lies in the future for database as a service? Database management traditionally is very demanding. The requirements in IT to manage a number of complex and skill-demanding tasks, including not just installation and configuration, but also tuning, upgrades, patching, replication, clustering, and load balancing, is difficult considering we are doing more with less every day. Cloud and other as-a-service options, especially database as a service, promises that we won't have to worry about management activities. As a cloud administrator, you are able to automate these demands, and EM12C will just manage them for you. This allows them to focus your resources, as in the business, on more important tasks and projects that are valuable to the growth of the business. Again, doing more with less. EM12C automates many of the tasks that are still a manual step on Amazon and other cloud tiers. The cloud administrator now has a product that specializes in database tier service and yet can handle middleware and platform tier 2. This offers the DBA an interface to set up the configuration and then automate and manage the environment to serve up demands for cloning, refreshing, upgrades, and other tasks that commonly hog resources for the DBA's day-to-day life. If we think about database as a service from the cloud computing characteristics perspective, we see all the scalability of the Enterprise Manager Database as a Service environment. It provides elasticity, scale out, and scale in. The database can grow and shrink automatically based on both read and write loads across the platform as a service. There's no downtime and without any changes required at the application tier. It has release scaling. The database can handle multiple replicas of the data and can be used to roll back to a previous snapshot of the environment without the requirements of a DBA and no DBA manual intervention. It can be done by the requester, of the user of the self-service portal. Pay per actual use. Chargeback, we all know that it's important to the cloud. It can be set up to serve the business or the consumer, making them more accountable to IT resource usage. Last but not least, multi-tenancy. This is the main feature of Database 12c. Any number of databases can run on any set of container databases. Resource consumption shrinks, and resources are shared by multiple pluggable databases. This is what DB12c was meant to provide. We hope to see future development to support the virtualization that many companies have already embraced, allowing VM environments to build large private clouds to be managed through EM12c Database as a Service infrastructure. There is also talk of multiple Exadata machines being knitted together into monster private clouds. This is being talked about with the acquisition of Nimbula, offering the customer super machines to support their environment. The ability to add on Exadata extended storage to be used for snapshots is an attractive option as well. Oracle provides a number of documents to offer you more information on EM12c as well as DBaaS, along with the Database as a Service cookbook. Everyone should go out there and check it out. All of this just made a career in the DBA world more exciting. More tools, more automation, more capability with less. What do you think? I thank you for spending this time with me today while I introduce you to Database as a Service. I welcome your comments and emails. Please contact me and consider joining Oracle in the social media community. This slide provides you with the links to Oracle Enterprise Manager's website, where you can easily research more information on EM12c and Database as a Service. Below this are links and information on me, Kellyn Potvin. This includes my Twitter handle of DBA Kevlar, my LinkedIn connection info, my blog, dbakevlar.com, my About Me page, which contains a large amount of data on what I've been up to lately, and my email address for any questions and comments. Thank you again for joining me today, and have a great February.